fleet problem. Okay, so let's understand what is a car fleet here. Okay, so there is a lot of information given, but I'll just simply go and explain. So basically we are given position, we are given speed. Okay, so and this is the target, and we have to figure out how many car fleets are going to be there. Okay, so let's suppose there is this car, there's one car here, one car here, and one car here. Okay, and we have to reach this guy. The point, and suppose there's four cars. Now, as no cars can overtake other. Okay, so even if this is faster, this cannot go before this cannot go before this cannot go before this. So at a moment, suppose if this car is having a lower speed and this car wents ahead and it touches this one. Okay, then it cannot go beyond. Okay, and it will make a single car fleet. Suppose in future this car also comes and joins this car, so this becomes a car fleet of three cars. Okay, and then they will go together, they cannot overtake. And suppose this car doesn't comes and joins this, it stays behind, right? So there will be two car fleet, one car fleet is this and one car fleet is this. Okay, to understand the solution, we'll suppose we are given here position and speed, right? So what we will do here is we'll create a single array. Okay, with position and speed, okay, position 1 speed 1, position 2 speed 2, like that for all the cars, right? And then what we have to do is we have to figure out at what time the car will reach, at what time the cars will reach the target. Okay, so we'll sort it down, we'll sort it. Okay, so the reason is, so so if the last car, okay, we have to check out from this side, because this, suppose this is the last, there are five cars. Okay, there are five cars, then even if all the cars are faster, this car will be the boundary, right? They cannot cross this car. So we'll start checking from the behind at which car reaches at what time. Okay, and then we'll save that in a stack. Suppose this car reaches in 3 seconds. Okay, so let's put 3 seconds in the stack. Okay, now the second car. Okay, suppose this car reaches in 2.8 seconds, right? The target, so we'll add 2.8 second. But again, at the 2 point, in between this time, it will go and collide, not collide, it will join this car, right? The car before, because it was taking more time, right? So then what we will do is we will consider this as the same, and this will also reach at 3 seconds, so I'll pop it. Next, this car. Okay, suppose this reaches at 2.5. Again, because of this restriction, 3 second, it cannot go. But suppose there's a car 4, it take 4 seconds, right? So it will take 1 second extra. So once this all the cards which is reaching at 3 seconds reaches, then the 4 second car will come and join. Okay, so this is the basic logic. Once we code, we'll try to understand it more. So we are given position, speed, let's create a pair. Okay, let's create a pair. So let's say const pair equal to position dot map, and we'll take the position and index, and we'll return an array with position and the speed of the same car. Okay, and so the most important guy here is the last guy, the car which is closest, right? Because if it is slowest, then it will decide the fleet number. So we will try to reverse it, so sort it in a descending order. So we'll say pair dot sort, sorry, pair dot sort, and to sort it in descending order, we can say b0 minus a0. Okay, looks cool. Now we have sorted it out. Now we need a stack, right? Const stack equal to a stack. Now what we will do is we'll say, okay, for const for every position and speed pair of pair. Okay, what we are doing, we will simply push it first. Okay, we'll say okay, stack dot push this PNS. Okay, we pushed it. Now see, we can only compare two elements if there are two elements, right? So we'll say if after pushing stack length become greater than equal to 2. Okay, one is this condition, other thing is, so now we have a greater than equal to 2, and then also what we have to check is if. Okay, so what we will do is, if what is the time taken by the car which just now reach. Okay, so we have to figure out that. So instead of pushing the P and S, we'll push the time taken by this car. Okay, this is what we were doing here, right? We're pushing the time taken. So the time taken by this car will be target minus position, that is the distance, divided by speed. This is the time. So what is the time taken by the current car? That is nothing but stack top, correct? Stack top. If this is less than, if this is less than, equal to. Okay, so now this thing basically says now to that if current car and the previous car, okay, the current car take lesser time, then it means it will reach faster, but it cannot because the previous car is holding it, right? So if the previous car is holding it, then we can simply say don't just remove it. Okay, because it will be dependent on the previous car, and if it is not dependent, it will stay there, right? It will stay there with a fresh new time of much lesser time. Okay, so basically suppose the previous took 3, now it took 2 seconds. So if any new car come, it will first check, okay, 2 seconds is here, and if it is reaching faster than 2 seconds, it will go and combine with this. If it is taking more than 2 seconds, 3 seconds, sorry, 4 seconds, like that. If it's taking more than 4 seconds, then it will come behind. And as we are removing the cars which is making a fleet, and the car which is which are becoming the obstacle, right, that will keep staying. So they are the one which will create the fleet. So we can simply return stack dot length. So this will be the total number of car fleets. Let's run it. Submit.